I will now move on to describing the features of our new products. These features are classified into 4 major categories: expansion of application range, pursuit of high productivity, improved usability, and enhanced environmental performance. I will begin by describing the first category of product features, expansion of application range. Next, let's look at the effect on the U-series. Like the S-series, the Y and Z-axis travels have been extended to 450 mm and 380 mm, respectively. The jig area has been further expanded by extending the Y and Z-axis travels and optimizing the installation position of the tilting rotary table, while maintaining the maximum jig size of 500 mm in diameter. The maximum height when the A-axis is tilted 90 degrees is 50 mm higher than the previous model. So, a jig height up to 320 mm can be secured. In addition, the tool accessibility at the lowest point of the Z-axis has been improved. When the A-axis is tilted 90 degrees, the distance between the tabletop and the spindle nose end has been reduced from 95 mm to 65 mm. Therefore, more stable machining is possible by setting the tool length shorter. When the A-axis is tilted more than 90 degrees, the tool can easily approach the end of the workpiece even for a tall workpiece. We have strengthened the spindle lineup. The spindle speed of the standard specifications has been increased from 10,000 revolutions per minute to 12,000 revolutions per minute. In the example of clutch housing machining, the cutting time is shortened by raising the rotation speed of small diameter tools to 12,000 revolutions per minute. This has achieved a 4% reduction in overall cycle time compared to the 10,000 revolutions per minute spindle. The next category of product features is pursuit of high productivity. The Speedio has been created through machine controller integrated development. Optimized control of the Speedio achieves non-stop ATC and simultaneous operation, thoroughly eliminating wasted non-cutting time. The shortest tool change time is 0.6 seconds for tool to tool. The new magazine load conditions estimate is provided on the new model, and this function can further reduce tool change time. In addition, detailed performance enhancements, such as optimized Z-axis control, have further improved productivity. Machining time per inverter case cycle has been reduced by about 3% compared to the previous model. In addition, Speedio's productivity can improve even further, depending on customers' operating conditions. The new magazine load conditions estimate estimates the balance of the entire magazine based on the shape and arrangement of the tools in the magazine to prevent situations where it may be unbalanced. Then, the acceleration is increased according to the conditions to shorten the tool change time. The table load weight estimate, previously provided only on the U-series, is now provided on the S-series to maximize the acceleration of additional axes. In addition, the automatic door opening and closing speed has been reduced by 20% for all new models. These improvements can help further improve productivity depending on the options or conditions selected by customers. I will now introduce the new No Warm-Up Support function that enhances productivity. Many customers warm up their machines before starting operation to stabilize machining accuracy. As you can see from the name, the new No Warm-Up Support function eliminates the need for warm-up operation. Touch probe measurement is performed at the start of the program, and the displacement of XYZ axis is compensated while continuing machining to maintain stable accuracy. Meanwhile, an original algorithm automatically reduces the frequency of touch probe measurement, as the displacement decreases after the start of operation, minimizing effects on productivity. Let's look at this function in more detail. As an example, take a workpiece that includes machining sections requiring strict accuracy. In case 1, when warm-up operation is performed until the accuracy stabilizes, wasted time not used for production increases. In case 2, the cycle time deteriorates because touch probe measurement is performed each time before machining. Since the No Warm-Up Support function automatically reduces the number of touch probe measurements, productivity can be increased while maintaining stable machining accuracy. The next category of product features is improved usability. The new model is provided with improved tool cleaning capability and the new Stuck Chips Detection function to prevent defective workpieces due to chips stuck to the tool holder. Compared to the previous model, tool cleaning capability has been tripled by reviewing the shape of the spindle flange, greatly reducing the risk of chips stuck to the tool holder. Even if stuck chips occur, the Stuck Chips Detection function alerts the operator before defective products are produced. From this model, the new Stuck Chips Retry function has been added. When stuck chips are detected, this function automatically performs tool cleaning again to remove chips without stopping the machine. The next feature is improved chip evacuation performance. To improve the chip shower performance, we increased the coolant flow from the upper section by approximately 10% by increasing the number of nozzles and enlarging the size of the pump piping. We also enlarged the chip outlet at the rear of the machine to make chip flow easier. These measures have reduced the risk of chips remaining in the machine. As monitoring functions to prevent problems, an ATC monitoring function is available to monitor incorrect tool attachment or omission of tool attachment. A machining load monitoring function is also available to detect an increase in machining load. Problem prevention is supported by detecting defective ATC or machining with these functions. As measures for automation, a side shutter is available as a new option. In addition, the side opening height has been increased by 120 mm. This makes it easier to avoid interference with robot joints when customers modify the side cover for installing a robot. The last category of product features is enhanced environmental performance. As Speedio's energy-saving measures, the machine's power and air consumption has been reduced to improve energy-saving performance when the Speedio is in operation. In addition to Speedio's high energy-saving performance, effective use of the new chip shower energy savings operation can reduce power consumption by approximately 30%. Furthermore, air consumption has been reduced by 20% by reviewing the spindle labyrinth structure and the spindle air blow timing. The new chip shower energy savings operation efficiently controls the chip shower pump that consumes a large percentage of power in a cycle, greatly contributing to energy savings. When this function is enabled, the control is changed so that the chip shower is turned on immediately before the end of the program. In this way, chips are discharged by the minimum activation of the pump, greatly contributing to energy savings. When the amount of chips in a cycle is large, using the intermittent setting can turn the pump on and off repeatedly. This can reduce power consumption while minimizing risks of residual chips. To further contribute to energy savings, the new energy savings mode has been added. This function turns power and power supplies on and off for power-consuming equipment. In addition, the required airflow rate for the entire machine has been reduced from the previous model by reducing the spindle air purge and optimizing the air blow discharge timing. For the U500XD2, spindle specifications can be selected from the standard 12,000 revolutions per minute and the optional 16,000 revolutions per minute. Travels of X, Y, and Z axes are 500 mm, 450 mm, and 380 mm, respectively, securing a jig mounting area of 500 mm in diameter with a maximum height of 320 mm. Users can now handle large workpieces and design jigs more flexibly, which contributes to process integration.